All right, we're going to look here at a problem that we briefly touched upon the way to solve this in 4.5, but we're going to look at a little more detailed here in 4.6 and get some more practice at. Now, if you look at this on first look appears like a fairly complicated problem. There's no easy way to factor this. There's no way to group this or factor. There's no GCF. So what we have to do is we have to use our rational root theorem. Now, what that states is that the possible rational roots have to be quotients of our constant and our coefficient, our largest coefficient. Now, what that means is that we look at our constant here. So our constant is 8, and our largest coefficient is 1. So what that means is our possible zeros have to be in this set of numbers right here. So what we do is we look at all the factors of our constant. So 1, 2, 4, 8. Okay, the first step is find all the possible factors of our constant. The next step is to look at our largest degree coefficient. So our largest degree term here is 5, and its coefficient is 1. Okay, so let's examine a little deeper what this rational root theorem tells us. So again, first step is to take all the factors of our constant, which we did right here, and take all the factors of our largest coefficient, which is just 1. The only factors of 1 are 1. What that means is that our possible zeros have to be one of these numbers. So we take all of the factors of 8 and divide that by all of the factors of 1. So what we're going to get here is plus or minus 1 over 1 plus or minus 2 over 1. Now I know these are just whole numbers. I'm just writing this out so you can see it. Plus or minus 4 over 1 and plus or minus 8 over 1. So what we've got here is we have 8 possible numbers because we have to take the positive or the negative. We've got plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. What that means is that our rational zeros have to be one of these 8 numbers. Now, we could still have irrational zeros, and we could have imaginary zeros, but all of our rational zeros have to be one of these numbers. Now, the reason this is important is that right here, when we first look at this problem, we really don't have any direction. Our zeros or our solutions could be any number, an infinite number of solutions. So I know that when you look at this set of 8 right here, it doesn't feel like it's giving you much help. But when you think of the fact that when you first start this problem, you have no idea what the possible solutions are, narrowing that down to a set of 8 numbers is a pretty big jump, or a pretty big help or hint. So what we need to start doing is taking these numbers and just start using synthetic division to see if any of these solve our problem. So if we do synthetic division right here, we get 1. Remember, we don't have x to the 4th, so we get 0. We get 1 for x to the 3rd, negative 2 for x squared, negative 12, and negative 8. Now, the next thing we need to do is just start plugging these values in and see what you get. Now, you guys know how to do synthetic division, so if you want to go ahead and pause right here and start plugging some of these numbers in, you can go ahead and start doing that. So again, I'll give you a chance to pause. This is what you're going to want to use for your synthetic division setup, and you can start going. I always suggest starting with positive 1 and then negative 1, then 2 and negative 2, and just keep going. Eventually you're going to hit a number. You know that your solutions your rational solutions have to be contained in this set right here. Now, if you had a coefficient in front of here, let's say 2, then your denominator would have to be 1 or 2. So this number set would grow by 8 more numbers, because you'd have to do 1 over 2, 2 over 2, 4 over 2, 8 over 2. Now, you'll see that some of those numbers would repeat, so you wouldn't do them twice. So it wouldn't quite be twice the many numbers. You would get to cancel out the repeats. Okay, anyways, I hope you guys were able to go through and find some of the numbers. So once you find one of your roots, what you want to do is go ahead and use the new polynomial that you got from doing your synthetic division and start repeating the same process on that lesser degree polynomial. So when you find a root, you take that root out, use your smaller fourth degree polynomial, and continue this process until you've now either factored it as far as it can go, or you've got all 5 of your solutions. So you know that we're going to have 5 solutions here. Now, when you were doing your synthetic division, you should have figured out that -1 is a 0 and 2 is also a 0. Now, it turns out -1 is a 0 that repeats twice. You found that out if you started using -1 again on some of your simplified down polynomials. So right now we only have 3 of our 5 zeros. And if you do synthetic division with 2 and -1 here, you'll see that we end up with a quotient of x squared plus 4. So again, since -1 is a solution, we know that our factor had to be x plus 1. And also, since 2 was a solution, we know that one of our factors was x minus 2. Remember, our factors are always the opposite of our solutions. And since -1 is a 0 repeated twice, we know that our factored out form is x plus 1 squared times x minus 2. Now, what you should have left after you've divided your original polynomial by -1 twice and by positive 2, you should be left with x squared plus 4. Now, at this point, what we can do is we just set x squared plus 4 equal to 0. And that's how we can go ahead and get the remaining solutions right here. So what we get is we get x squared equals -4. And when we go ahead and take the square root of both sides, we get x equals plus or minus 2i. We take the square root and we take out the negative, and then the square root of 4 is 2. Okay, so those become our 5 solutions. We've got -1 twice, 2, and then plus or minus 2i right here. All right, so as we click through, we find that plus or minus 2i. So what that means is that our factored out polynomial looks like this: x plus 1 squared times x minus 2 times x plus 2i times x minus 2i. And all 5 of our zeros, like we said, -1, -1, 2, -2i, and positive 2i. So again, feel free to go back and read any of this again, or listen to any of this again. And if you had any problem factoring this, go back and check it out and see if you can, redo it after going through it a couple times.